Hey guys, this is Mrs. Scott, and I am here to review some of the questions from practice test 2 with you. And particularly today, we're going to talk about the calculator questions. So we predetermined some questions that are commonly missed, but of course come to the academic support time, specifically for the SAT during your free periods during the school day if you have questions on any other problems from this test that I don't go over. The first one we're going over today is number 13. Honestly, guys, this one took me a second. I am not a stats teacher here. Obviously, I've studied stats. It's just not my thing. So this one took me a while to think about, but I've got it a good way to explain it here. A researcher conducted a survey to determine whether people in a certain large town prefer either watching sports on TV or attending the sporting event itself. The researcher asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following makes it least likely that a reliable conclusion can be drawn? So here's the deal. Okay, the correct answer is D, where the survey was given, but let me explain why. Doesn't it make sense that if I was conducting an experiment, and I wanted to know if people liked to watch sports on TV or in person, it wouldn't make sense just to go to a restaurant on a Saturday. There's sports on Saturdays, so we're gonna assume that the people at a restaurant on a Saturday will probably say that they like to watch sports on TV. They would be at a sporting event if that was their preferred situation, or at least we can kind of assume that. So it's the location. That's not really giving us a good picture of what everyone in the town would have to say, okay? Another example of this is if I was taking a survey here at Front High School about kids who have after-school jobs, who has an after-school job. It wouldn't make a lot of sense to, after school, go to the media center and survey those kids, because if those kids are there after school, they obviously don't need to get to a job, at least right away. Okay, so it might not be a good picture of what the overall conclusion might be. So that is the reason why the answer to number 13 is D, where the survey was given, makes this an unreliable result, okay? So then no math involved there, just stats and thinking about conducting research. So let's go on to number 15. This says the distance traveled by Earth in one orbit around the sun is 580 million miles. The Earth makes one complete orbit around the sun in 1 year. Of the following, which is the closest to the average speed of Earth in miles per hour? Okay, so here's the math. The answer is A, but here's why. 1 year is 365 days. 365 days is 8,760 hours. I just got that by taking 365 times 24 hours in a day. And then what we do is we take the distance of the Earth around the sun in 1 year, and we divide it by 8,760 hours to figure out miles per hour. Okay, miles over hours, and that came out to be about 66,000. It wasn't exact, but about 66,000 miles per hour, which is pretty wild because we look at the sun and it seems like it takes forever, but really the Earth is moving so fast. Okay, cool. That was number 15. The next number we're going to do is number 17. So in number 17, it says the atomic weight of an unknown element in atomic mass units is approximately 20% less than that of calcium. The atomic weight of calcium is 40. So here's the deal. 20% less means this. We need to find 20% of that number. So 20% of 40 is 8. How did I do that? Well, I could take 40 times 0.2. That's one way to do it. The trick I do is I take the decimal, move it over one spot, that's 10%, and then double it. That's how I also tip at restaurants. So 20%, move the decimal over, double it. That's where we get 8. And it's 20% less than that 40. So I actually have to take that answer and take 40 minus that answer, and that's where we get the answer of 32. So a lot of students forget this last step and they just skip right to answer choice A, seeing that first part of their answer coming up in these solutions kind of throws a lot of kids off. So don't forget that last step of subtraction. Okay, so we're gonna move on to number 18. This one took me a while too, but there's a very specific way I think about skewedness, and that helped me get this answer pretty quickly. So a survey was taken of the value of homes in a county. It was found that the mean home value, mean is average, was $165,000, and the median was $125,000. Median's middle number. Okay, so which of the following situations could explain the difference between the mean and median? So think back to when you first started learning about measures of central tendency, meaning mean, median, mode. You should have learned at some point here at Fremd that if the mean is equal to the median, then that means we have a nice bell symmetric curve. However, if one is greater than the other, so if the mean is bigger than the median or the median is bigger than the mean, then that means that we have some skewedness to the distribution of the data. So when the mean, in this situation, the mean is greater than the median, and this means that the data is skewed to the right. What that means, you guys, is that there is an outlier that is on the high end. In other words, there are some homes that are worth a lot more than that median amount, okay, which is going to skew the data. It's going to take the mean and it's going to make it bigger. So the way that so the answer choice is C. There are a few homes that are valued much more than the rest. Whoops. That was weird. But so that's the answer. But the way that I think about it, I always think back to the classroom, okay? This is how I remember skewed left versus skewed right. I always remember, I memorized the classroom grades are usually skewed left. And the reason why they're skewed left is because a lot of the times, you know, students will get A's, B's, and maybe C's on tests. But then if you have two kids fail, it takes the average and it moves it down. It moves it down a lot. So that's when the mean is smaller than the median. So when I was doing this problem, I thought, okay, wait, the mean is bigger. So this is the opposite. Instead of having F's, there's really high grades. It's not grades, it's cost, but there's really high costs. And that's the way I thought about it. So there are a few homes that are valued much more than the rest, and that is because the data is skewed to the right. Let's go on. The next problem we are going to do is number 22. So guys, when I first read this, I just read this and I was so confused, but they give you some information up here. So they give me an equation and it talks about what each letter represents. At a large distance R from a radio antenna, the intensity I is related to the power of the signal. So this one says, which of the following expresses the square of the distance in terms of the intensity of the radio signal and the power of the signal? All you need to know is what you're solving for. And so expresses the square of the distance tells me that I'm solving for R squared. So I'm going to take the equation they gave me and I'm going to get the R squared by itself. So I would start by multiplying over the 4 pi. So that gives me 4 pi times I equals P over R squared. Lots of different ways to solve this. I would probably multiply over the R squared. And then to get the R squared by itself, I would actually divide over this 4 pi I. So it would leave me with R squared equals P over 4 pi I, which is answer choice B. Moving on to number 26, it says the complete graph of the function f is shown. Which of the following are equal to 1? So I did some highlighting here. F of -4, I highlighted in red. So that's the x value is -4. The y value there is 1. So this equals 1. So that one is a yes. F of 3/2, that's 1.5. I highlighted that in orange. X is 1.5. What's the y value? It's also 1. So that equals 1. That one's a yes. And f of 3, I highlighted in green. X is 3. Y is also 1. So all three of these are equal to 1. So the answer choice is D. 1, 2, and 3. I would argue you didn't need a calculator for that one. right, guys, I'm going to move on to these grid and answers. We're going to do 3 of them together, and that'll be it. So starting with number 33. They throw a lot of these in the SAT, a problem like this where you're solving for a letter, okay? Don't overthink it. It says in the xy plane, we have the point 36, and we have this function, 3x squared minus bx plus 12. So what is the value of b? So we want to plug in this point. The x value is 3. I'm plugging it in for this x and this x. The y value, or the f of x value, is 6. I plug it in there, and then I'm going to evaluate. So I get 6 equals 3 squared is 9. 9 times 3 is 27. Minus 3b. Okay, plus 12. Okay, so the 27 and 12 combines to 39. Minus 3b equals 6. Subtract over the 39. That gives me a negative 33 equals negative 3b. And divide over the negative 3. So positive 11 equals b. And that's it, guys. So we just plugged in that point xy and solved for b. Love the next one in number 34. This is an Algebra 1 problem. A little disguised as a word problem, but it's Algebra 1. It's a system of equations. In one semester, Doug and Laura spent a combined 250 hours in the tutoring lab. If Doug spent 40 more hours in the lab than Laura, then how many hours did Laura spend? So this is a system of equations. There's 2 situations. The total amount of time, so Doug's time plus Laura's time, is 250 hours. It's the second equation that I always struggle with. Doug spent 40 more hours. A lot of students want to say Doug plus 40, but that's not how it works. Doug's total amount of time is 40 more than Lori's. Okay, so, or I keep saying Laura, whatever. You guys get the idea. Okay, so whatever Laura's time is, we're going to add 40 to it, and that gives me Doug's time. So that second equation's a little harder to come up with. But now it's just, once you get it, it's just solving a system. So Doug is equal to 40 plus L. Let's replace the D in the first equation with 40 plus L. Okay, and then I still have that plus L equals 250. So all I did was replace this D with 40 plus L, which is equivalent to D. All right, so combining like terms, I get 40 plus 2L equals 250. So 2L equals 210. Subtract that 40 over. And divide by 2. We get Laura's, not Lori, Laura's time is 105 hours. Which means Doug spent 40 more than that. So if it asked for Doug's time, you would have to take that and add 40, say 145. But it asked for Laura's. Always check what the question's asking. It asked for Laura's, so we're done. Okay, and here is the last problem I'm going to do with us today, and it's a quick one. So again, the SAT, they're going to give you problems that seem complicated. This should be a quick problem. You don't need a calculator for it either. Jane made an initial deposit to a savings account. Each week thereafter, she deposited a fixed amount to the account. In the equation above models the amount A in dollars that Jane has deposited after T weekly deposits. According to the model, how many dollars was Jane's initial deposit? So we want to know at the very beginning, when there were no deposits yet made, what was that initial amount? So that's going to be at 0 weeks. How much money is there? Well, I can plug in 0. So that's 18 times 0. A equals 18 times 0 plus 15. So that's 0 plus 15, which is just 15. So another way to think about this is the y-intercept. The y-intercept always represents an initial amount. Okay, so the y-intercept of this linear equation is 15. That's another way to think of it. Okay, and then if, again, just be careful of the question. If it asked how much was she depositing per week, that would be the slope. That would be how much we're changing per week, which would have been $18. But that's not what it asked. It asked for the initial amount, which is that y-intercept at 0 weeks we had $15 in that account. So that's all I'm going over for today. If you guys have more questions about this test, pop into your SAT period Zoom and ask those questions. Thanks, guys.